Okay, so today we're going to start with an 820-3787 board that's not turning on. It's not completely dead, so if I plug in a charger here, you'll see that I can get a green and then an orange light on it. However, the fan doesn't spin, it never turns on. So let's try and figure out why that is. So the first thing that we would usually do in this situation is check out to see if there's any power rails missing. Anytime you have a no power situation, it's a safe assumption that a power rail that you would need is missing, and that's why you're not getting power. So first things first, I'm going to open up the schematic and board view software over here so that you can see everything. So let's just get to the proper page where you can see that stuff. Okay, so Hole F4, and you should be able to see the schematic in the board view now. So let's scroll down a little bit. Now, the most important page for me on this schematic is the page that lists every single power rail one by one. So I don't know where it is on this schematic. They used to have it on pages, like right in the beginning, around page 5, 6, and 7. And they used to have a diagram on pages 1 and 2. And now I have no idea where the hell they put any of this shit. Let's see. So let's open 3787. Here we go. So let's see, what page are we looking for here? Yep, only Apple. So when it comes to things that are important like power rails, most manufacturers will put that on the first page because it's the most important thing. When you're dealing with an Apple schematic, it'll be on page 81 out of 94. That's a nice middle finger, if I've ever seen one. So the first power rail here is PP bus G3 hot, and the schematic says that that's supposed to be 12.8 volts. So I'm going to use the board view software. I'm just going to type in PP bus underscore G3 hot, and it's going to show me everywhere that PP bus G3 hot shows up on the board. I'm going to arrange the board view software so that it's in the same orientation that I have the board in the table. Somehow the board view software always knows how to open itself up so that it's in a different orientation than it is on the table. So I'm going to plug in my MagSafe, and we're just going to take the multimeter, and let's see what voltage I get. So at that point, we put this into voltage mode. Now there's going to be two voltage modes in your multimeter. One is going to usually have a little wavy line, that's for AC, and the other one is going to have a straight line, that's for DC. We're looking at measuring DC voltage here. All these voltages are supposed to be DC, so set your multimeter to measure DC voltage. Take the black probe here, and I'm going to put it on ground, which is going to be a screw hole or any one of these large metal connecting or looking things on the board. So I usually use a screw hole, and then we're going to take the red probe and put it where the board view said PP bus G3 hot is supposed to show up. And I get 4.08 volts. Now in the schematic, it's supposed to get 12.8 volts. So the first thing I'm going to want to do here is try and figure out why it is I don't have the voltage that I'm supposed to. So let's move over to the chip that's responsible for it, which is U7100, which is... Actually, it's not I'm in the wrong schematic, aren't I? I am in the wrong schematic right now. I think I have two Sumatra windows open, and it's kind of screwing with me. I do, don't I? All right. Here we go. So let's go over to U7100, which is usually the first thing that I check in no power cases around this area. So let's take a look at this under the microscope. So I'm going to use the board view software to show me where U7100 is. You just hit C for component, and it'll show up. It'll open a window that allows you to type in the name of a component, and then it will show you where it is on the board. Of course, it's going to show you where it is on the board in the opposite relation that the board is on the desk. It always knows exactly what way I have the board in the desk so that it can open it in the opposite way. And this is U7100. So let's take a look in that area, and we're also going to look in the schematic and see if we have any idea what's going on. Now, if you look at it under the microscope, which I should probably plug in before I say let's look at it under the microscope. Let's wait a second for that to turn on. Here, come on. Good little microscope. There we go. All right, so let's look at that area and see if anything looks particularly funny. Now, does anything look bad here to you? This is one of those cases where if it looks bad, it is actually something that you can use. So, yeah, come on. I'll give you guys a second to tell me if anything looks bad there. This is not our usual liquid damage case. There's no liquid damage to this machine, but there's something else. Didn't get it yet? Still not? Okay, I'll show you. Let's get my tweezers. See this with the little hole in the middle of it? That's no good. So let's just zoom in a little more, because I know you may be saying, what do you mean a hole in it? I can't tell with YouTube compression what the hell that is. All right, so let's zoom in a little more so that you can see what I'm talking about. Now, on the left resistor, it's a little less pronounced than it is on the right resistor. On the left resistor, it looks like a little bit of brown in the center of the resistor and a tiny protrusion. But on the right resistor, it's a very clearly pronounced black dot, and that clearly pronounced black dot is where the resistor itself blew up. So when resistors die, resistors don't usually die where they go from being, let's say, 10 ohms to being 0 ohms. They don't die where they turn into a wire. They die in the opposite way that, let's say, a capacitor usually dies on in these boards, where the resistor turns into just a pile of mush. So it usually fails open, where it doesn't pass any electricity at all. So let's just go over what that is for in the schematic here and show you what that circuit does. So this is R7021 and R7022. This is part of a current sensing circuit that uses the shunt resistor R7120 to go to the ISL6259 in order to tell the machine how much amperage that buck converter is using. So this here, this U7100 circuit is a buck converter. If you don't know what a buck converter is, watch the buck converter series videos that I've done that explain exactly what a buck converter is. So long story short, this takes the 16 to 18 volts from your charger and turns it into 12.8 volts for the machine to run off of, and that's what this entire thing does. So it pretty much switches back and forth between 16.0, 16.0 in order to average it out to 12 to get you to 12 volts. Now, the computer is going to want to know how much current this circuit is using. Let's say there's a short circuit inside your machine. Let's say something bad happens or liquid gets spilled on it. The machine is not going to tell the charger to stay on, because if you have the charger stay on when there's a short circuit to ground or there's liquid spilled, the charger may blow up or get destroyed, or something terrible may happen. So there's something called current sensing going on here. And what it does is it tries to tell how much current the system is using. Now, there's usually not a noticeable voltage drop across a resistor. It's not like you have 12 volts on one side and 1 volt on the other. But across this resistor, there's going to be a really tiny voltage drop. And the ISL6259 is going to measure the difference in voltage between the top of this resistor and the bottom of this resistor. However, the ISL6259 here does not have a direct path to the top and the bottom of this resistor. What it has is these two resistors in between, so that, you know, if anything goes wrong in the current sensing area, instead of blowing up the ISL6259, which costs, you know, more money than, let's say, a resistor, it just blows up these two stupid little resistors instead of destroying your entire system, which is a good thing, because this chip connects directly to the SMC, it connects directly to several other things, so you don't want 16 volts potentially going to your SMC with a surge just because the current sensing circuitry decided to go poof or do something silly. So you have these resistors in between. Now, there's going to be a small voltage drop across R7120. Now, that voltage drop is going to be proportional to how much current or amperage the system is using. And this is how the U7100 is able to report to the SMC how many amps the charger is using. You'll also see we have a current sensing circuit over here. It's the exact same thing, except over here it's for the battery. And these two resistors went poof. Now, one great way to figure out if anything in the circuit is wrong, instead of having to see, is the path from the ISL to the resistor good? Is the path from this resistor to the shunt resistor good? Is this resistor good? Is the path from the shunt resistor to R7021 good? And is the path from R7021 to this good? What you can do to measure the entire circuit in one measurement is measure the resistance between pins 27 and 28. Because if you measure the resistance between these two pins and everything is working, the number that you get should be the series addition of the sum. I'm being an idiot. Series addition? Where the fuck did I get that from? The sum of all the resistors in the circuit. So R7022 is 10 ohms, R7020 is 0.02 ohms, and R7021 is 10 ohms. So you should get 20.02 ohms if you measure between pins 27 and 28. And when I measure between twins, wow, that that kind of sounds like the name of a porno. Between twins. When I measure between pins 27 and 28, I get 4.64 million ohms, which is very far off from the 20.02 that I'm supposed to get. So most likely those two resistors are bad, and they have to go. And when they do go, there's a very good chance that this will actually work. So let's get started Turn on the hot air. Turn on the air filter. And off they go. Whoa. These are standard people tweezers, by the way. These are not the regular ones I use. Look at how unfit they seem for this job. I mean, like asking an elephant to sign his name with a fine point pen. Yeah, there was a little bit of dirt in there. Clean that out. Okay. Now let's grab 2 more 10 ohm resistors. I come prepared. I have a spool of them. Alright. Oh, these tweezers are awful. Oh, and they get magnetized super easy. Seriously? This is dog shit. I really should just get up and get my other tweezers. I don't know where these came from. Fuck you. Okay. Let's just do this one at a time. If this video does anything, it denotes the importance of using good tweezers. Let's get good tweezers. Alright, now let's try to do that same job, except now with a proper tool. This is the proper tool, but it's a broken version of it. These tweezers are really messed up. But you'll see how much easier everything is when you just have the proper tool. See? Nothing. It's way too much flux. I do that so I can get trolled by EEV blog people. I'm just going to start adding flux to everything. I'm going to start a cooking channel and have Amtech 559 on everything. See? Good tool. It's like, just bam. Thank you. By the way, if you're wondering what caused this, 99% chance this was a knockoff charger. Now, what a lot of people do also that I want to point out here that's wrong, they place the resistor and then they try to hot air it. I don't know what it is, but so many people have something against simply holding the resistor in place. Like, I just did that, and I got it right in the pads. But that doesn't always happen. Most of the time in these videos, you'll see that what I do is I hold the resistor while I'm putting it down. This way I can ensure that it doesn't move. Okay, everything there looks like it's back in place. I can put my 10 ohm resistor spool away. I'm sad that I lost one, but that's what I get for being lazy. kick off all the noisy stuff. Still dead. Ha! Alright. Now we continue. Let's see what we get. So PP bus G3 hot is 3.967. Did I really fix my current sensing circuit? Let's go back to resistance mode measurements here. I'm going to measure the resistance between pins 27 and 28, which were for the current sensing circuit. And let's see, ideally I should have 20.02. And I have 4.65 ohms again. Let's see, I put in a 10 ohm resistor. And that 10 ohm resistor is reading 4.52 kilo ohms. Great. I put in a 10 ohm resistor. That resistor is reading 143 ohms. WTF. Let's try this again. Let's see, what 1/16 of a watt is what I have my resistors at, and the schematic says that those are supposed to be 1/16 of a watt, 5% tolerance. So what the fuck? Is something else killing it? Yeah, it's always possible that something else is killing it. Alright, so I tried to do the quote-unquote correct thing and take the resistors out of a new spool. Now I'm going to do the incorrect thing and make the trolls angry. And just take the resistor off of I'm just going to take the resistors off of a donor board. See what happens here. Fine, fuck it. And this time I'm going to measure the resistance before I turn it on and after I turn it on. We'll see what's causing this bullshit. That's a nice certified pre-owned resistor. Another certified pre-owned resistor. I didn't see that. Flow it into place. Okay, now this time I'm going to measure the impedance, or resistance, before and after. So before I turn it on, 10 ohms, good stuff. The other one, 10 ohms, good stuff. Okay? Now I'm going to plug the charger in, and I'm going to look under the microscope at those resistors while I'm plugging the charger in. Let's see if anything funny happens here. Any funny business happening here? I don't see anything blow up. I also don't see anything turning on. Well, let's see. PP bus G3 hot at this point is 4.02. Resistance of my resistors is 316 ohms. Okay. And 1.5 million kiloohms. So now what I'm going to do is I'm going to measure for a short to ground anywhere around that area to see if that's what's killing me. And of course, this is interesting. So on this side, let's do this in split view so you can see what the fuck I'm talking about. Alright, so check this out. So this, on the top, that's where it's coming from the shunt resistor. On the bottom of each resistor, that's where it's going to the chip. So over here, I have, on diode mode, 0.481, which is not a short to ground at all. And on this side over here, I have 0.013, which in the context of this circuit is a short to ground. So let's take a look here. We're going to take the hot air, and what if this capacitor over here is actually going to ground? So what if this capacitor here is what's bad, and it wasn't that the resistors were bad, but rather that this capacitor is actually killing my current sensing circuit? Because one of the things you may notice is there's actually, on each one of these current sensing lines, there is a capacitor going to ground. Now, it could be something different. It could be that the ISL itself is bad, or it could be that this capacitor is bad. But there's only one way to figure that out. So let's disconnect the capacitor and see if that's bad, if that's going to ground. So I do this, and I do this, and I still have a 0.013 measurement, which means, and let me just show you where that is on the schematic. It's time to actually put this into context. So right over here, so let me just make sure I'm in the right space. R7021, right over here, on this end of the resistor, there is a short circuit to ground. Now, there are two ways that this could be shorted to ground. It could be shorted to ground by C7121, which I just removed, which did not remove the short, or the U7100, this could have failed and also shorted to ground. So the U7100 is what failed because when I removed the capacitor, we still have the same exact trait. So now we have to replace U7000, and I also have to, U7100, I have to replace the buck converter IC, but then we also have to replace the damn current sensing resistors again, because I'm an idiot who didn't realize that the first time around. Great. Alright. So this is the third time that I'm going to be replacing the same thing because I was being an idiot. So first things first is to put that capacitor back on because that capacitor did nothing wrong. And now is to remove the current sensing resistors, which I'm going to have to replace, and also, of course, the ISL 6259, which was the culprit all along. There's no space in this desk. I tried to move the board up so you can see it better in the microscope camera, and I do that and I hit the damn keyboard. Move the keyboard up and the keyboard hits the television. New York is great. You don't have space for shit here. That's me soldering like an ape, according to Shock on EEV blog. I kind of enjoy soldering like an ape, though. It's like my... I should make that my logo. Like, instead of a sheep, I should also have an ape logo. Be an ape next to it. So I don't really post on forums. Like, a lot of people have suggested that I post on these online forums, and it's like, why would I bother? Really? Why the fuck would I go out of my way to do that? It's mostly just a bunch of... It's kind of like the same reason that I'm not really, you know, the most sociable person, you know? Meeting new people sucks. Just a bunch of people that are going to go out of their way to insult people they don't even know. But, like, there are things I say on this channel about people who... But they're usually people that I know, or people who've personally caused me loss of money, loss of time, or just gone out of their way to make my life difficult. But, like... And I'm sure that that's going to get more widespread the more subscribers that I get. It's like a lot of that crap that I read online. It's like there's like a lot of hate when I had like 4,000 subscribers. Even back then, I really didn't care about joining forums and talking to people very much about this stuff. It's just so much snark, and who needs it? Okay. Much rather stay here in my jungle and be an ape. Kind of like being an ape. Eat my banana. Play my Donkey Kong. Hello. Hello.
Louis?
Hello?
This is Louis?
What's up?
This is Sean.
How's it
California.
How's it going, Sean?
Good, buddy. How are you?
Tired. What can I do for you?
I am exhausted, too. Quick question. I mean, get this real quick. I have a 2012 A1398 15-inch, okay? I know the recall with Apple, etc., etc. Scrambled screen, but when I do it to an external monitor, it's completely clear. Is that the video? Is that the GPU?
Define scrambled for me.
It's flickering.
Does it...
I don't know if it's a bad LCD, or I can see some of the depth. It's scrambled. The lines up.
I would...
I can see kind of the depth.
Okay, if you run GPU test, does it crash?
I haven't yet.
Was it dropped? Was it liquid damage, or was it something random?
Something random. She said she didn't drop it. And she's already had it. I've already sent her to Apple probably 6 months ago. They replaced the board already.
Make them do it again and demand a 2015 Retina for all of her troubles.
Okay.
I mean, it's mostly...
What about the data?
I would just charge. I guess you can charge them to back up their data, or you could just take the SSD out and just ask for a tip and be nice. But that machine is just going to be a clusterfuck if you actually try to fix it for the ladies. So what I would do is I would just tell them I can take the SSD out for you and put it in a little bag, and you can take this to Apple and just have them replace the board for her. Again, it could be the screen. It could be the MUX, which is what switches between internal graphics and internal graphics and the GPU. Because there are different pathways for the I think there's different pathways in that machine for the graphics to get to the external monitor versus the regular. So I'm pretty sure it's the graphics chip, though, just from what you've described. And she just probably got another shitty board from Apple.
Okay. Now my question next to you is, if I pull that SSD and put it in a bag for her, will Apple say someone's been in the computer that we're not going to work on it?
What you should do, because the thing is, Apple is very likely to do that and pull some bullshit. So what I would do is I would tell the customer to tell Apple, the last time I went here, they took the SSD out of the computer and put it in a bag for me. So what you're going to do is tell her to tell the Genius Bar clerk that the last time I was here about this issue, they said that they could take my SSD out and that they did it. Because that works. I've used that on people before, and that works. Because they come back and they tell me, yeah, it worked, thank you. Or otherwise, they're just going to wipe her data and be pricks for no reason.
Absolutely. Perfect. I appreciate the advice, and I got another one that's telling me that's going to I'll get an email about that.
I was happy to see that you fixed the one with the keyboard issue after the class. That was...
I've done probably 10 at least after the class. If you need any, like, I don't know, advertising, I don't know, if you need any, like, I don't know how to say it, any good things about the class, if you're doing, let me know. Just always shoot me an email if you need any prior client reviews or anything like that. Always let me know.
It's funny, you called in the middle of a YouTube video, so you're actually going to, this phone call is going to wind up being in a YouTube video. So if this board works and doesn't go on fire, this will actually serve as my advertising.
That sounds wonderful. Louis, Keep it up, man. You're an inspiration.
Thank you, Sean. Let's see.
All right, buddy. Take care.
See you later. And just as he says that, the board actually works. See, Sean Calling was my good luck charm. He was a student that came to the class, and he also came to my personal tutoring here for a week. He went from not fixing backlight fuses on this stuff to fixing like quarter fan spin and like LVDS mux issues and no keyboard because I had to run jumper wires all over the board, and it's pretty cool. I like the thing I like about Sean is he's one of those people that is down to earth, honest, and humble. So even if he knows something or he knows something that you don't know, he's not going to act like an asshole about it. He's always a down to earth, humble, really nice guy. Like, you know, not like most of the dickheads that I meet in New York. But, you know, I'm really happy when I see people like that are successful. Like, again, I still remember there was this one dude that came here, and he said, you know, I've just been working at a recycling company for a really short period of time. Before that, I was a pizza store clerk, and I worked at a pizza store. And and there was another person that I had here at the same time, and it was a particularly insecure person, and he's asking about, you know, the backgrounds of all the people coming in. He's like, pizza store? Well, how is he going to expect to learn this when he came here from a pizza store? Well, the first guy, the pizza store dude, fixed over 21 boards within less than a month of going back home to his company, and the guy who was making fun of the pizza store guy has he's not fixed over 20 boards. So, you know, it's just one of those things where, you know, I really like seeing humble people become successful. And, you know, it's just, you know, cherry on top when it's because of my teaching. But yeah, check it out. So we had a current sensing issue, and the current sensing issue with the current sensing circuit went dead after the current sensing section of the ISL 6259, which is the buck converter chip over here. Dull. I just closed the window by doing that. Went dead. So what went dead was the current sensing section of U7100. It shorted to ground right on this pin, on CSIP. And when that happened, it would kill this resistor because you'd pretty much be sending the 16 volts from the charger. The 16 volts coming to the charger would pretty much get shorted to ground at this particular point. And it's actually good. Again, if this resistor wasn't there, you'd be shorting the charger to ground and destroying a lot more stuff. So it's good that R7121 is there. It's good that R7121 kept it from dying. And it's good that this works because it means I get to give it back to my customer. And yeah, that's pretty cool.